Okay, that's great. Okay, that's good. So now what we will do today is understand the basics about hypothesis testing, and then we'll go further into how to use Jamovi for the hypothesis testing. And this is one of the very, very important aspect in not only your research paper, maybe in your own research that you're doing it, or even in some of the practical and industry exposure also this will be required. That way this comes to very, very important aspects. So understand the concept. I'll try to be as lucid as possible. I'll try to simplify as possible because you are coming from the varied background. So I'll see to it that you all get it crystal clear what it is about. So before going with that, let me talk about a basic thing that we did it in the first session itself about the statistics. So we know now that the level of measurement, okay, we know about this level of measurement. Mainly they are classified into two: categorical and numeric or scale. In categorical, we can go further: nominal and ordinal. Now, why I'm repeating this? Because based on this, we have already studied which central tendency to use, okay, which dispersion to use, and which graph to draw. And if you recollect, one of the slide that I gave it in the last session was why this level of measurement is important. So one, to understand or to summarize it correctly, means rightly use mean, median, and mode on or standard deviation and all. Secondly, to draw an appropriate graph. And third is to decide suitable test, hypothesis test. So all these three, out of that, this we have already done in my first session. So today we'll focus on the concept of hypothesis testing, that is called the parametric test. And then we'll go to this feature that if it is a nominal or ordinal or numeric, then which test to decide. I'm again repeating, in this world of softwares, in this era in which technology is with you, you don't have to worry much about how to do that. It is just the steps. It is a matter of practice. What is important is for your problem, for your data, which statistical test fits best. And then to interpret the result that we get from it. That is where today we will focus on. And then I'll give you hands-on also how to do on Jamovi. And it will be hands-on. So I'll be sharing you the data set. If you want, you can practice it simultaneously, or you can write down the or note down the steps, and then through the videos, which you will be getting the video link later on, through that you can practice it on your own with the different data sets. Either I had the data set that I have sent to you, or your own data set you can practice. Okay, so shall we start? Everyone, Princey, what do you say? Shall we start? Okay. Write down in the chat box how many of you say it's we are you are ready for it. Jenny. Okay, Veena, Mr. Kiran. How about others? Asgate, Subhashri, Veena, Pushpa, Jenny, Dr. Ranganan. Okay, that's good. Sure. So as I said, I want it to be very interactive. So wherever you are stuck up, you're not clear, write down in the chat box. I will revert to that. Because I want everyone, those who are investing time, should get the value for the time that you have invested. So the basic thing that we'll start with is what is population and what is sample. And I'm sure this everyone knows. But still I'll touch upon that. So population, we know that it is the total number of units under the study. total number of units under the study. Suppose you want to check that how many diabetic patients are in India. How many people are diabetic in India? Suppose this way. In that scenario, to check whether an individual is diabetic or not, I need to go to each and every individual in India. I need to go to all Indians. And that becomes my population. If I want to check that how many four-wheelers in Tamil Nadu, say for example, I'm focusing on Tamil Nadu, how many four-wheelers are having black films on their glass? In the cars that the four lights glass that we have it, how many of them are using black films, which are legally not allowed? But how many are using it? So then what to do? All four-wheelers that are there in Tamil Nadu becomes my population. Okay, and now we know it is not possible to go to each and every individuals of India and ask whether they are diabetic or not. It is not possible to check each and every four-wheelers in Tamil Nadu and check whether they are having black films or not. So what we resort to? We resort to sampling. So we'll select few individuals from India. Now we'll see to it that the sample that we select, few individuals that we select, it they represent the whole Indian. Means I will take from different states, I'll take rural and urban, I'll take according to the religion, I will take according to the income group, I'll take according to the gender. So all the diversity should be covered of the population should be covered in my sample. And so the definition says representative part of the population is called a sample. Representative part. So the part which represents the whole population, that becomes your sample. Okay. Now, whatever calculations you do on the population observations are called parameters. And whatever calculations you do on the sample observations, they are called statistics. Okay, Sridevi, Dr. Pauline, Bhagyalakshmi, that's good. So getting the idea? So anything that you, or a measure that is you calculated on the population observations, they are called parameter, and calculated on the sample observation, they are called statistic. Make sense? Now let me check. If I say mean, which is the notation immediately that comes into the mind? Honestly, which is the notation that comes? Is X bar. Someone say it is mu. Okay. But when is mu and when is X bar? So now that comes to the point that this is X bar is for the sample mean. And this mu is for the population. So the first thing you have to remember when we talk about mean, mu stands for parameter. That is the population. So this parameter is nothing else but for a population. And for a sample, it is statistic. If I say standard deviation, you all know the notations will be sigma and S. If we talk about proportion, it will be capital P and small p. If I talk about correlation coefficient, it will be rho and R. This is rho, RHO. So if I do the calculation for the whole population, they are called parameters, and these are the notations for mean, standard deviation, and so on. For sample, these are the notations. Now understand what is happening. I wanted to check what is the proportion of diabetic patients in India. Okay, I wanted my purpose, my objective, my problem statement is I want to find out the proportion of diabetic patients in whole India. So what will be my population? Population will be all Indians becomes your population. I wanted to check for whole India. I want to check the proportion of diabetic patients. Means actually I want to find out capital P, because you know capital P is for the population. But we all know it is not feasible. Practically, it is not possible to go to each and every individual and ask about it. So what we do from India, we say we roughly take 50,000 individuals. So we are taking sample now. 50,000 individuals from different states, different district, different locations, different religion, different gender, different income group, and all we have taken care of. And we take 50,000, that is a sample. Suppose out of this 50,000, if I say 5,000 were diabetic, so what becomes that proportion? 5,000 upon 50,000. How much it comes to? 10 percentage? So 0.10. Which is this value? This is a proportion. Proportion of what? A sample. So what is the notation for that? Small. So we get the answer that it is 10 percentage. Okay, but that is for what? Sample. Now, honestly, what we do, we wanted for the whole population. We wanted for the whole population. That means I want the value of capital P. But what we do, we find out the sample. And then we conclude that that will be the same answer for the population. Means after this survey, after this research, I will conclude that 10% of the whole Indians are diabetic. This is normally the practice. We have to do for population, which is not feasible. We'll do it for the sample. Whatever answer we get, we'll say that is the same answer for the whole population. Now, this is a conclusion. This is an assumption that we are making it. Now, we want to check whether the assumptions that we have made, what is the assumption? That 10% based on this sample. Can I say that will be the same answer for the population that is for the whole India? Now, that is to be checked. That assumptions need to be checked. And that is where we come to hypothesis testing. That is where we need to go for inferential statistics. So now going to that detail, I'm skipping this part because Raju sir has already taken descriptive part. So what is inferential? Inferential means to predict about or to estimate about the population based on the sample. So I'll repeat again. Actually, we wanted to study the whole population, but practically it was not feasible. We took a sample. We studied the whole sample. We found out its result. And then we conclude that the same result will be for the population. That is called inferential statistics or inferential data analysis. Because we are inferring, we are concluding about whom? About the population. Based on whom? Based on the sample observation. That is called inferential. I'm not going into detail about this. Yeah, hypothesis testing. Now, what is hypothesis? First, let me break it out. Hypothesis is an assumption. Now, these assumptions may be based on the data or it is your pure guess, pure assumption. Say, for example, the problem that we took from the India, all Indians, we took a sample of 50,000. We got a small proportion of 10%. Then we are assuming it, isn't it? Then we are assuming that the same answer will be for the population. So that is our assumption. We want to check our assumption. That is why it is called hypothesis testing. Testing means checking. We want to check whether the assumptions that we have made, assumptions made based on what? Based on the sample. So whether the assumptions that we have made from based on the sample, is it true or not? Is it right or wrong? That is we need to check. And that is why hypothesis testing comes into the picture. Now, the application part, if I say, almost all your study will be based on sample only. Whether you want to study the IQ level of students, whether you want to study the psychology of the students, whether you want to check the marks, whether you want to check the correlation between the income group and the marks obtained, you want to check whether there is any relationship between, say, the locality and the case of income, all that is based on sample. And then we make a guess, then we make an assumption, then we make a hypothesis that is the same answer for the population. And so hypothesis testing becomes a integral part, I would say integral part of any analysis, any research, or any kind of papers that we publish. This is must. Okay, now there are two types of hypothesis, null and alternative. Many of you, those who know statistics a bit, those who have applied statistics a bit, you may be aware about it. But I'll go as if you're not knowing it. So don't worry. Because there are certain myths. Because in majority of the books also, there are certain things which is written, which is, I would say, not true, to be on a safer side. They are not 100% true. Or I would say they will misguide us. So today, I will take in an industry perspective that when we do consulting, how we do it out, it becomes easy for the practitioners like you, for academic or industry to apply this knowledge. Okay. Null hypothesis is nothing else but a statement about the population parameter. What was the statement we made? That the population of India, out of that, 10% will be diabetic. This is a statement about what? The population parameter. Or if I want to compare, say, Tamil Nadu and Gujarat, I want to compare where there are more diabetic patients. So proportion of diabetic patients in Tamil Nadu is P1, proportion of diabetic patients in Gujarat is P2. I want to compare where there are more diabetic patients. Okay, I will say Gujarat is considered to be the hub of diabetes. Gujarat is considered to be the hub of diabetes. ये जो होते it is average, that's true. Okay, so we say that Gujarat is having more diabetic patients compared to Tamil Nadu. Now again, this is your null hypothesis. Okay, I'll say Gujarat is having more or at least greater than that of Tamil Nadu. Now this is also null hypothesis. So it can be about a single proportion or single population, or it can be relationship between the two parameters. So what is a general statement? A general statement about the population parameter or about relationship between the two or more population parameter is called null hypothesis. So in short, null is nothing else but a statement about population parameter. Now there are two types of null hypothesis, simple and null. When your null hypothesis takes single value, specific value like equal to, just a 10%, so it is 10% exactly. Okay, if I say what is the average income of Indians, average income of Indians per month, average income, suppose I say 20,000 is the average income per individual, so average. So if I write down a specific value, single value, that is called simple null hypothesis. If I make a statement that on an average monthly income of Indians will be less than or equal to 30,000. I would say not more than 30,000. Proportion of diabetic patients in India would be less than or equal to 10%. So I'm giving range of values. Here it was specific 20, only 20,000. Here I'm giving range 30,000 or less, 10% or less. Then it is called composite null hypothesis. If you give exact single value, it is called simple null hypothesis. In majority, I would say majority of the books, they follow only this much. And that creates a confusion. I'll take how to solve that. So in short, what to remember? Null hypothesis, the important part. Null hypothesis can be pure equal to, it can be greater than or equal to, it can be less than or equal. If we use pure equal to, then it is called simple. If we take greater than or equal to or less than or equal to, it is called composite. Everyone is with me? Okay. Next, it comes to alternative. So alternative means complementary to the null hypothesis. Complementary to the null hypothesis is called alternative hypothesis. Now, here is the catch. Here is the logic that will be required. Let me explain. If I make a statement that 10% of Indians are diabetic, this is my statement. So this becomes my null hypothesis. In how many ways, you can contradict to my statement? In how many ways you can contradict? You can say, no, it will be less than or equal to 10%. It can be less than 10%. You can also say, no, it will be more than 10%. In both the cases, you are contradicting my statement. This means that the summary of this two, if I take it out, it comes to not equal to 10%. I repeat again. If I say average income, monthly income of Indians is 20,000, in how many ways you can contradict? Very simple. When I say it is equal to 20,000, you can say it is not 20,000. That's it. So you can say it is not equal to 20,000. But if I make a statement that average income of Indians is less than or equal to 30,000. Now important. What will be the option left? If I say less than or equal to 30,000, what can be the complementary to this? So write down in the checkbox. In the checkbox, you write down. If I say it is less than or equal to, what will be complementary to this? Good, Divana. It is greater than anyone else? Okay, Jenny, Vina. Okay, there's someone with Motorola. Okay, Jyotish. Good. That's great. So if I say less than or equal to, just see the number line. Chalo, make it very clear. I'll make it crystal clear for you. I'm saying 30,000. So what is the statement I'm making? Less than or equal to 30,000. So what is left out? Only this part is left out. So this means mu greater than 30,000. If I make a statement that average income of Indians will be at least 25,000, at least 25,000. So what will be complementary to this? I'm saying greater than or equal to 20,000. So what will be left out? It will be less than 25,000. You can see if I make it equal to 20,000, then what happens? I'm saying it is 20,000. This one. In how many ways you can contradict to my statement? You can say it can be greater than also, it can be less than also. So you can go on both sides. Now, as you can go on both sides, that is not equal to, and this is called two-tailed test. Because not equal to means what? It can be greater than also, it can be less than also. So it is called two-tailed. What about this case? Greater than 30,000. So I can move only on one direction. I can move only over here. So that is called one tail. Same way, less than means I test one tail. So let me summarize this part. Okay, Dr. R. Vetrivandan. What does this mean now? This means If your null hypothesis is equal to, if it is equal to, alternative will be not equal to, and that is called two tail. As I explained, why two tail? Because if I say it is 20,000, exactly 20,000, you can say, what? It will be greater than 20,000, or you can say it is less than 20,000. So greater than or less than means it is not equal. The second option, if I say mu is greater than or equal to 25,000, this is say 25,000. I am saying greater than or equal to 25,000. What is left out now? You can go only on one side, that is over here, that is less than. So whenever it is greater than or equal to, the option that is left out is less than. Same way, whenever it is less than or equal to, the option that is left out is greater than. This is how null and alternatives are decided. This is how one tail and two tail is decided. So now keep it clear. Not equal to means two tail. Less than means we are able to go on only on one side, and that too on the left hand side. It is called left sided one tail. Greater than means we can move only on one side, that is right hand side. It is right sided one tail hypothesis. And if you are able to understand null and alternative, 90%, I'm repeating, 90% of your hypothesis testing is done. Whether you talk about parametric, non-parametric, ANOVA, correlation test, regression test, all requires the logic of null and alternative. So now let me take some case studies to clarify that what can be the problem and how we can frame null and alternative to this. This is a problem that I've taken. So look at the problem, read the question. Sure. What is the question? Jamestown Steel Company manufactures and assembles desk and other office equipment at several and so on. The weekly production of the model in the Florida area is normal with a mean 200 and a standard deviation 60. Recently, because of the market expansion, new production methods have been introduced and the new employees hired. The vice president of the company would like to investigate whether there has been increase in the average weekly production of the model. Okay, so what is the problem? Let me summarize it. The company is manufacturing this kind of table and chair, ready-made table and chair, and they came to know, okay, and they also know that their average sales was 200 and standard deviation 16. That was according to the historical data of the past sales. Now they came to know that business is expanding, offices are increasing, and so more people will be required, or more people will have a demand of this kind of tables and chairs, office equipment. And so what they did, they introduced a new manufacturing unit, they recruited new employees and so on. So they invested in that. Now once we invest, the owner, the manager, the president always ask, I have invested money in it, have my sales increased? Okay, that is the question. Okay, now how to address this kind of problems? Let me go systematically. First thing, we need to understand what is the parameter of the question that is asked. Which is the parameter of, or which is the decision variable? So I'm going one step back. Which is the decision variable? Which is the parameter? I'll ask these two things. Now, as we are doing it for the first time, let me explain what it is. We'll read the question. The vice president of the company wants to investigate whether there has been increase in the average weekly production. So which is my variable? Variable is weekly production. What they want to know? Do they want to know the correlation? No. Do they want to know the proportion? No. What is the parameter they are focusing on? Average. So the parameter they are focusing on is average. mu. So this is the first thing you need to understand from any problem which you are solving for the industry or your own research problem. That what is your decision variable and what is your parameter. Okay, once it is done, now see what is the question. We'll focus on the question. What is the question asked? The vice president of the company would like to investigate whether there has been increase in the average weekly production. So they are asking us whether there is an increase. What can be the answer for this? If someone asks you, is there increase in the weekly production? Your answer can be yes or no. Only two answers possible because they are asking the question, is there increase? So you can start with any one of your wish. You start with any one answer of your wish. You can say, yeah, there is an increase. Suppose you say there is an increase. I say there is an increase. Okay. What was the initial weekly sales? Their initial weekly sales was 200. I am saying it has increased. Increase means what? Mu greater than 200. Make sense? I am saying it has increased. So what was before? Before it was 200. Now it has increased means mu greater than 200. What will be complementary to this? For greater than, what are the other options left out? If I write down greater than, what are the other options left out? Other options left out is less than or equal to 200. Great. Yeah, that's true. Yeah, Subhash. It is less than or equal to. Okay, less than or equal to. Both can be the case. Because here we are talking about only greater than. So what is the option left out? Less than or equal to. Out of this two, where you have an equal to sign, we have an equal to sign over here. So this becomes our null hypothesis and this becomes our alternative hypothesis. Because equal to sign was here. And null hypothesis should always have an equal to sign. And so this is my null and this is my alternative. Little bit you are clear? I have taken 4 or 5 case studies, don't worry. Take the next one. Coca-Cola company purchases 10-ounce bottles from a glass company. The glass bottle. The company wants to be sure that the bottles meet the specification on mean internal pressure or bursting strength, which for 10-ounce bottle is minimum strength of 200 bottles per square inch, PSI it is called. Will glass company meet the Coca-Cola's company specification? This is a practical. I have taken all real case studies. Okay. So first step, everyone focus over here. And if you're not clear, write down in the chat box. I'll repeat it again. First step is to go for decision variable. Then write down is a parameter. Which is the decision variable they are focusing on? Which is the decision variable? The company wants to be sure that the bottle meets the specification on mean internal pressure or bursting pressure. Means the strength, bursting strength. So my decision variable is strength. You all agree? Okay. What is the parameter they are talking about? The parameter they are talking about is mean. That is average. So parameter is mean. That is mean. First is this step. Now, what is the problem? Question is asked, will glass company meet the Coca-Cola's company specification? What was the specification by the company? Coca-Cola company had this specification that the bottle should have minimum strength of 20 pounds. Minimum. Okay. What is the question asked? Now understand it again. What is the question asked? Will the glass company meet the Coca-Cola specification? Can be your answer? You can say yes or you can say no. It will meet or it will not meet. That are the only two possibilities. Start with any one. Suppose I say it does not meet. I say that the bottle company is not meeting the glass specification. Okay, Shubhasri, that's good. Okay, it does not meet. Does not means what? When it can meet, when it can meet, if it is minimum 200 pounds. So when I can say it is not meeting the specification, it is less than. If it is less than 200, then I say that the company is not fulfilling the Coca-Cola's company specification. Make sense? Because I've written does not meet. What will be complementary to this? I'm taking less than. So what will be complementary to this? Less than. So what are the alternative left out? What are the possibilities left out? Greater than or equal to 200. Here it was less than. What are the other options left out? Greater than or equal to. This means it meets the criteria. Out of this two, where we have an equal to sign, here we have an equal to sign. Here it is no equal to sign. Here it is an equal to sign. So this becomes your null hypothesis and this becomes your alternative hypothesis. This is how null and alternative is decided. Greater than or equal to perfect. I think you all are very fast. So why I'm explaining this? Because in majority of the books, what they do, they always start with null. They always start with null. They put equal to sign. And then they decide what can be alternative based on the problem. That creates a confusion. So that is very difficult to understand and to explain also to others. Okay, to the students, to the researchers, it becomes very difficult. Instead of that, the simple way is whatever the question is asked, think about yes or no. So take next. Read the question. Tell me what is the decision variable? What are the parameters I'm trying to cover? Once that is done, we'll read the problem and then we'll decide null and alternate. So write down in the chat box fast. What is the decision variable? A Raval, Anita, we are not getting answer from you. Make it fast. Boana, Dakshin, Dr. Augustine, Itta, Ilango. Make it fast. K Amutha. I want everyone to write down. Right or wrong, it's okay. That's good. Okay, parameter is mean, monthly unpaid balance. That's good. Anyone else? Unpaid balance, unpaid balance. That's good. Very fast. Okay. Yeah, do write down in the chat box. So the decision variable is what? The Thompson's discount application store issues his own credit card. The credit manager wants to find out whether the mean monthly unpaid balance is less than $400. Mean unpaid balance. Okay, Pushpa, Dr. Augustine, that's good. Sridevi, that's fine. So this means they are talking about unpaid balance. They are talking about what? Mean. Mean means average. That is mean. This is what we have. Okay, mu and so parameter is clear. Okay, Bhagyalakshmi, you've written the both answer. That's good. Now check the question. Okay, first understand the problem. What is the problem? Thompson discount store owner and so on. So the credit manager wants to find out whether the mean monthly paid is less than $400 or not. Baki sab bhul jao. Forget the previous thing. Only thing that the manager wants to know whether the mean monthly paid balance is less than $400? What can be our answer? Yes or no? Very simple. We can start with yes or no at your wish. Suppose I say yes means it is less. Less. Less than what? Mu is less than 400. Less than $400. What will be complementary to this? For less than, what can be the complementary? Okay, Shubhasri, perfect. What can be this complementary? It will be greater than or equal to $400. What this means? It is not less than. Out of this two, where you have an equal to sign, we have an equal to sign over here. So this becomes my null, which is called H0. This becomes my alternative. This is your H1. Simple. This is the most difficult, to your surprise, this is the most difficult part of hypothesis testing. Rest all softwares is there for you. Okay, Dr. Agustin, Veena, someone with a Motorola, Sridevi, Pushpa, that's great. Divana, sure. Next, go through it fast. Now we'll make it a little bit fast. Decision variable, parameter, and then we'll decide null and alternative. So what is the problem? I'll understand. Make you understand. A person living in a particular locality, they wants that there should be a bus in that route. Now the suburban transit authority, like we have BRTS and all that kind of thing, they say if from your locality, at least 55% people says that okay, we'll travel by this bus, then we'll start with this route. Normally that is a scenario worldwide. Commuters, okay. So we will say potential commuters. So we'll make it simple, commuters. What is the parameter? Percentage, 55 percentage. Percentage means proportion. Percentage is nothing else but proportion. Okay. So this is my decision variable and my parameter. Yeah, Shruti, it is percentage means proportion. Now, we'll decide null and alternative. What is the condition? At least 55 percentage of the potential commuter indicate they would use a particular route. What is the question asked? Does the Bowman to does the Bowman to downtown route meet the STA criteria? Estimate Suburban Transit Authority. This is STA. Does it meet that criteria? The question is asked, does Bowman to downtown route meets the STA criteria? What can be your answer? Yes or no? So we say, suppose, yes, it meets the criteria. Meets the criteria. What is the criteria? At least 55 percentage. At least. This means P greater than or equal to 55 means 0.55. What will be complementary to this? If it is greater than or equal to, complementary comes to less than 0.55. Out of this two, where you have an equal to sign, we have an equal to sign over here. So this is null. This becomes alternative. I hope the picture is clear. Okay. Maybe Jyotish, Sridevi, Ekta, Pushpa, that's good. This is how null and alt. Once you decide null and alternative, believe me, the things, other things are very, very easy for you. So, next. And then we'll move to the Jamovi part. Same thing. I want decision variable. I want parameter. And then we'll go further. What will be the decision variable? Parameter mean. Okay. Decision variable appliances sold. Okay. Sales, Divana, that's good. So we can say decision variable is sales. What is the question asked? Tom Savitz is the owner of this company. Okay, is the owner of an appliance patch. Recently, Tom observed the difference in the dollar value of sales between men and women he employs as a sales executive. A sample of 40 days reveals that men sold a mean of 1400 worth of appliances per day, while with the standard deviation, so and so on. So it is given. So you can say sales also. You can say the value of appliances also. Okay, that's okay. What is the parameter? Average, because they are talking about mean. What is the question asked? Can Mr. Sevitz conclude that mean amount sold per day is larger for the women? Getting the idea? He wants to know, does female sales more? The sales of females are more compared to that of male? That is what they want to check. So suppose I take mu m is the average sales of men. Mu w, I am taking average sales of women. You can use mu1, mu2 also if you want. But right now, to make things easy, WM, mu M is for men, average sales of men, and mu W is average sales of women. What is the question asked? Mean amount sold per day is larger for women. So, what we can do? We can say yes or we can say no. Start with any one. So, suppose I'm starting yes, mean is larger for women. Mean is larger for women. So this means if I write down mu w and if I write down mu m, which is larger? Average sales of women is larger. Larger means it is greater than over here. What will be complementary to this? Complementary to this will be mu w less than or equal to mu m. This is how null and alternative is decided. Okay, Shubhasri. Divana, nowadays you can see, understand it is one tail. Okay, Pauline. Okay, Sri Devi, Shubhasri. Now getting the idea, null and alternative. We'll take sums also based on this. This was just a case study kind of thing to clarify your null and alternative concept. Sure. We'll move. So there are many more examples. I'm not going into that right now. Next part is very important, is when to use which test. Again, that is the idea about level of measurements. If your level of measurement is scale, just go back to that mean median wala. If your measurement is scale, you need to ask the question whether it is normal or not. Whether it is normal or not, that we need to check. Today I'll explain how to check normality. Whether a data is normal or not, how to check, today I'll explain it using Jamovi. So fine. The first thing we need to do is to identify a level of measurement. Is it categorical or it is numeric, that is scale? If it is scale, we need to check whether it is normal or it is not normal. Okay. So I'm starting with the first scenario that my decision variable is scale and it is normal. Then the next part comes, what is your parameter? Is it mean or it is standard deviation? Suppose it is mean, then for one sample, you have to go for one sample t-test. For two samples, you can go for T for independent samples or T for dependent samples. This is T for dependent sample. If it is more than two, we have to go for ANOVA. And if it is repeated measures, then it is ANOVA with repeated measures. So I repeat the logic again, how to decide. We have now seen how to identify your decision variable. We have now seen what is the parameter we are talking about. So if your decision variable is say scale, we need to check whether it is normal or it is not normal. If it is scale and it is normal, then we have to go for average or we can go for standard deviation. If it is one sample, do it again. If it is one sample, it will be one sample t-test. For two samples, there are two options. Either the samples are independent or the samples are dependent. Now, what does that mean? Independent means I am taking sample from Gujarat, I am taking sample from Tamil Nadu. They both are independent. I would not say that the individuals who are diabetic in Gujarat will be affecting the of Tamil Nadu or they depend on Tamil Nadu and so on. They are independent. But if I say I am taking, say, IQ test or say statistical awareness test, statistical knowledge test. Suppose for you all, there are 51 participants. I take statistical test before this workshop. So there are 51, 1, 2, 3, 4, up to 51. And I take the same test, statistical test, after the workshop also. Then they are dependent because the samples are same. They are the same 51, but we are observing it before some experiment and after some experiment. Then it is called dependent samples. So when the sample units are same, here you can see the individuals in Gujarat and individuals in Tamil Nadu are separate, they are different. So when the units are different, it is independent. When the units are same, it is just like before, after, then we say it is dependent. Or it is also called, very famously called as a paired t-test. Okay. Next, if it is more than two samples, more than two, and if we want to check the average, we have to go for ANOVA only. Okay, Vina, you want to get it repeated? Okay, let me explain. So what to do now? First step. Okay, let me give you the whole process. First, identify your decision variable. Your decision variable can be categorical or it can be scale. If it is scale, ask the question whether your data is normal or it is not normal. If your data is normal, then the parameter can be mean or the parameter can be standard deviation. So this is how you have to reach. Once you go up to this, then we have to find out. If it is one sample, then it is one sample t-test. If it is two samples, then you can say independent sample or you can go for dependent sample. If it is more than two samples, then we have to go for ANOVA. And here, if it is dependent, then it is ANOVA with repeated measure. This is how we have to go for ANOVA and all. Units different and units same. Okay. Yeah, Bhagyalakshmi, I'll explain today how to check whether the data is normal or not. let me take an example, Vina, to explain you. If I want to check whether the diabetes scenario, or say road accidents, proportion of fatal road accidents are same for Gujarat, Maharashtra, and say Rajasthan. Average number of fatal accidents per day, per month, whether it is same for the three or they are not. So the number of fatal or average number of fatal accidents in Gujarat would be different than that of Maharashtra, would be different than that of Rajasthan. So these are called independent samples. They are called independent samples. But if I say, again the same example, you are 51 participants, I take a statistical test before workshop. I take statistical test after day 1. I take statistical test after day 2. I take statistical test after day 3. And if I want to check whether the workshop is successful or not, you can see the units are same 51 participants, but they are observed with the different time frames. Then this is ANOVA with repeated measures. Here they are independent. Units are different. The number of fatal accidents in Gujarat, number of in Maharashtra, average number in Rajasthan, they are different. So we have to go for ANOVA. Okay, more than two variables, ANOVA. Yeah, that's true. More than two samples, not variables. More than two samples that you take, then you have to go for ANOVA. Now, if my focus is not mean, I want to check the standard deviation. I want to check the standard deviation means what? I want to compare, say for example, Ahmedabad and Mumbai. I know that average income of Mumbai is more than that of Ahmedabad. So I'm not concerned about that. That I know. That average monthly income of Mumbaikars are more than that of Ahmedabadis. I'm not focused with that. I want to check where the variability is more. Variability means fluctuations. Among the data, where the fluctuations is more. Income fluctuations is more. Now that comes to the problem that I want to check the variance or the standard deviation, because standard deviation measures the variability. Because we know in Mumbai we have posh area like Narimal Point and Ville Parle, and we have Dharavi, the slums also. So there is a lot of variations in their income. I want to check, does Mumbai has more variability in the income compared to that of Ahmedabad? That means my focus is not mean, my focus is variability. That is the standard deviation. So if your focus is standard deviations, then you have to go for chi-square test for one sample, F test for two samples, and for more than two samples, Bartlett test, or there is also Levin test. And we are going to cover all of this. Everything will be covered, don't worry. Majority will try to cover it. If your variable, decision variable is scale, but it is not normal, possible, the data is not normal, then we cannot go for mean, we have to go for median. That we have done it in my first lecture. In my first lecture, we have done when to use mean, when to use median, when to use mode. If you recollect, the data can be nominal or that is categorical. Suppose it is nominal, ordinal. And we did central tendency and dispersion. If it is nominal, then compulsory we have to go for mode and we cannot use dispersion. If it is ordinal, we have to go for median and we have to go for interquartile range. If you recollect that session. If the data is scale, Then we have to ask the question whether it is normal or it is not normal. Suppose it is not normal and it is normal. If your data is not normal, recollect it. Then again we have to go for median and you have to go for interquartile range. If it is normal, then only you can go for mean and standard deviation. So now you can see when the data is scale and normal, then only we can go for mean and standard deviation. If your data is not normal, here it is not normal, I cannot go for median only. This is the median. That is why median comes into the picture. And in that scenario, we have to go for Wilcoxon test for one sample, Mann-Whitney for two samples, and Kruskal-Wallis for more than two samples. If they are dependent, then we go for Wilcoxon for dependent and Friedman test. This all are called non-parametric tests. And this all are called parametric. And if your data is not scale, with a nominal, then we have to go for proportion, Z test for two sample, chi-square test, N test, chi-square test for two proportion, and chi-square test for more than two proportion. This slide is the most important slide for any analysis, inferential analysis that you go for. This will help you to decide which test to use when. What I will be doing it and what we will be doing it now, I will go with one sample when the data is normal. And if the data is not normal, we will go with Wilcoxon test also. This is what I'll be covering it today. That means I'll be covering it for one sample today. From in my next lecture, I'll be covering independent, dependent, Mann-Whitney, and Wilcoxon. That means I'll be covering for two samples. Raju sir will be then taking about more than two samples. Then we'll go for chi-square test. We'll go for chi-square test also. That is proportion test. And then we'll go for correlation, we'll go for regression and all. So that is the whole plan for hypothesis testing and further. Okay. Now we'll start with one sample. I'm sending some data files also over here in the chat box. If you want, you can download. Okay, if you want, you can download it and keep it with you. Or if you want to do it simultaneously, you can make it fast, but you have to do it with me if you want it. I've given a lot of data for practice also. I'll be explaining one or two, but remaining data set you can practice it for you. So let me start with it. One sample test. So steps. First step, null and alternative. Third step, which majority of the books ignore, but industry, researchers, publication in good research journals will require is to check the assumptions. That is step 3. I'll explain what it is. Step 4, it is simple, test statistics and p-value. Step 5, conclusion. And the conclusion is if p-value, because now software will give you p-value. Okay. If p-value is less than or equal to alpha, we reject. So don't get confused. When you are doing it manually, suppose I assume that suppose you all of you have not used any of the software till date, and you are doing it manually and comparing with the table value, then we say t less than or equal to t tab. We were saying null hypothesis accepted. And if t greater than t tab, we were saying null hypothesis rejected. Something of that kind we were using it. But now in software, no need to go for table value and all. Because the problem was for non-statistician, the problem was you have to use a separate Z table, separate T table, separate chi-square table, separate F table, and so on. Separate tables were to be found out, to be compared, and then the conclusion was done. Software has eradicated that problem. No need to look at T value, no need to look at table value also. Finished. You only look at the P value that you get from the table. So if P is less than or equal to alpha, then we say we reject. And if it is greater than alpha, then we fail to reject. Statistically, we never accept. We say the data does not help us to reject. So we'll say we fail to reject. But as a layman, we can say we accept the null hypothesis. These are the 5 steps that will be used for all the hypothesis testing. Step 1 and 2, null alternative. Step 3, assumption. Step 4, determining the test statistics and p-value. Step 5 is the conclusion. This conclusion remains fixed. P less than alpha, reject. Greater than alpha, we fail to reject. Okay, so we'll start. I'm now starting with t-test for single mean. When I can use this? Again, if I follow, I'll first go with decision variable. My decision variable should be scale. Then I need to check whether it is normal or not. If it is normal, then my parameter will be mean. And if it is for one sample, then I can go for t-test for sample single mean. So I need to check my decision variable whether it is scale or not. I need to check whether it is normal or not. I need to check whether the parameter is mean or not, and whether the sample is 1 or not. If it is more than 1, I have to go for different t-test. Okay, we'll do that also. Step 1 and 2, null and alternative. So either mu will be greater than, then alternative will be not equal to. If it is less than or equal to, it will be greater than. If it is greater than or equal to, it will be less than. That we already know now. Important is this assumption. So everyone pay focus over here. What is the first thing when we can use t-test? When your data is normal. So we need to check whether our data is normal or not, which many of you are asking the question how to check. The first thing we will do is we'll check whether our data is normal or not. And that can be done by Shapiro-Wilk test or QQ plot. There is many more tests. Anderson-Darling test is there, histogram is there, QQ plot is there, box plot is there, and there are many ways. But ideally, we'll go for this. And second, the most important, which many of you are not asking, but you have in your mind, that then when to use that test, isn't it? Because majority of the books, again, majority of the book says if your sample size is greater than 30, go for Z test, and if it is less than or equal to 30, go for T test. Isn't it? I'm sure many of the books or whatever you might have studied, if you have done, then that is in our mind that if the sample size is more than 30, go for Z test, less than 30, then go for T test. Isn't it? Yes, Kanjana? That's it. Kanchan, that's good. Ideally, when you're using software, no need to worry about all this. The reason is when to use Z test, you know when to use Z test? Z test is to be done when population variance is known. That means sigma. Sigma square is known. Do you know the reason? What is the formula for Z? Formula for Z is x bar minus mu divided by sigma upon root n. So if you know sigma, then only you will be able to substitute over here. Practically, we never know sigma. We don't know about the population parameter only. And so we do t-test. What is t-test? X bar minus mu divided by s upon root of n minus 1. We go for S. This is sample standard deviation. That can be obtained because we are collecting sample. So for sample, we can find out X bar. For sample, we can find out standard deviation and all. And so generally, we never go for Z test. Z test is not to be used or to be used only when sigma square is known. And that is the reason, see, the assumption says we need to check whether the population variance is known or not. Because if it is known, we have to go for Z test. I cannot go for T test. How to do that? If you read the problem and if you find out that population standard deviation is given, go for Z test. Step 4, test at a 60 and the p-value, and then it is conclusion. This remains the same. P less than alpha, reject, greater than alpha, fail to reject means accept. This is what you have. Sure. Now we'll start with the actual Jamovi. Hands on. Make it fast. So we'll open up Jamovi. I'm opening Jamovi now. Raju sir has explained how to load the data, how to go for exploratory. I'm not going into that detail. Okay. My Jamovi blank sheet is open. What is to be done? First step, load the data. So open, browse where your data is. And that too gram. My data is ready. Done up to this. Loaded the data. I've taken very simple small data first to understand. So what is the data? What is the problem? Let me explain here. Here it is. Based on the field experiment, a new variety of green gram is expected to give an average yield of 12 quintals per hectare. The variety of was tested on 10 randomly selected farmers' field. The yield was recorded as this so and so, so and so. Do the result conform to the expectation? Now see, this is a problem of agriculture. I'll start with the decision variable. What is the decision variable? Yield. That's good. Yield is the decision variable. Which is the parameter they are asking for? What is that? On an average. Average. This much is okay. So my decision variable is yield. My parameter is mu. Okay. Next part. If my okay, sorry. Decision variable is yield. and my parameter is average. That is yield. We know the yield of crop that we get, it is a scale. So that is clear that my data is scale. So now I need to check, okay, now I need to check whether it is normal or not. That will do it. Number one. Number two, how many times the sample is taken. So if you see the number of samples is only one, because only one type of the green gram was tested, and that too on 10 randomly farmers fed. So my number of samples or the number of times the sample is taken is only one. Now, question. What was this? Based on the field experiment, a new variety of green gram is expected to give an average yield of 12 quintals per hectare. It is expected that on an average it gives 12 quintals per hectare. What is the question asked? Do the result confirm the expectation? What will be the answer? Okay, Shubhasri, Jyotish, Veena, that's good. What is the expectation? That the average yield is 12. Question is that do the results confirm the expectation? Our answer can be yes or no. Our answer can be yes or no. We say, okay, yes, it confirms. We say it confirms the expectation. So we say yes. We say it confirms. What was the expectation? That on an average it will be 12. So we say yeah, it is 12. What will be complementary to this? It is not 12. Not 12 means it is not equal to 12. Out of this two, which you have an equal to sign, we have an equal to sign over here. So this becomes your null. This becomes your alternative. This is how things work. Okay, yes and no, it is done. Okay, so that is what I've done it in the next slide. Null and alternative is ready. And now you know that not equal to means what? It is a two-tailed test. It is a two-tailed test. So my step one and step two is done. Recollect. What was step three? My step three was assumptions. What were my assumptions? If I say step three, they were my assumption. There were two assumptions. Suppose I start with the first one, population variance. Read the question. Is population variance given over here in the whole sum, in the whole data? Is population variance given? No. If population variance is not given, Z is out of the picture. Z test is out of the picture. So that is why here in assumption, we'll say population variance unknown. So this assumption is been checked. Population variance is unknown. That is done. Which is the next assumption? Normality. Now we are going into that part is a normality assumption check. So what we assume over here, this is also important to understand. We are now checking whether my data is normal or not. Perfect. Now we are checking whether my data is normal or not. So in that case, I will say data is normal. That is my null hypothesis. And I'll say data is not normal. That is my alternative hypothesis. Always. So whenever you want to check the normality, you'll start with null means data is normal. Alternative is data is not normal. Okay. Now see, I'll explain how to check the normality. Done up to this? Any query? Fast. Any query? No. So now I'm going to Jamovi. This is my Jamovi file. I'll go into exploratory, go into descriptive. I repeat again, into exploratory. In exploratory, we go into descriptive. So now if you see into descriptive, my variable yield is been shown. See, by default, you see it is a ruler sign that Raju sir might have explained. The prefix of yield is a ruler sign. That means it is a scale. It is identified that it is a scale. So I want to do analysis on this variable, so I'll select and keep it over here. This Raju sir might have explained you. This is done. Now I want to check the normality. So in statistics, I don't need n, I don't need missing value, I don't need minimum maximum, I don't need minimum maximum. I want to check Shapiro-Wilk test. So here you can see in normality, see my cursor, there is a button called Shapiro-Wilk, isn't it? I'll click on that. That's it. My normality test is done. What I've done in exploration, I've gone into descriptive, selected my scale variable that I want to check, and then I've just tick marked on, it is written over here also, normality. So click on Shapiro. What is the result showing? My W value is 0.970 and my P value is 891. My P value is 891. So I'm going back over here. So what I've done in exploratory, I've gone into descriptive, I've selected my variable, I've selected my Shapiro-Wilk test. My P value, see now, my P value, which I'm sure you all will be getting it, 0.891. With what I have to compare? I have to compare with my alpha value, level of significance, which is generally taken as 5%, so 0.05. Generally, we take it 5%, so it is 0.05. What was my p value? 0.891. So I can say this is greater. It is greater. Now recollect this part. Yeah, this is greater means what? Greater means we fail to reject. We fail to reject means we accept. So here also, what we are getting at, we say P is greater than alpha. So we say we fail to reject null hypothesis. We fail to reject null hypothesis. Fail to reject means we accept. And what was our null hypothesis? Here, variable is normal. So that is why now I am saying, therefore, my yield is a variable, is normal. This is how normal, how simple it is. This is how you can check whether your data is normal or not. Any doubt? Anyone? No. That's good. So this means my step 3 is done. I have not completed my test. I have not completed my test. I have only done up to step 3. Because what was my step 1? Null and alternative step 1, 2. 3 was to check the hypothesis that I have done. Now I'll go with step 4. That is to find out the test statistics and the p-value. How to be done? Understand this part. I'm going with again Jamovi back. Okay, I'm going with Jamovi. I will go into analysis. I'll go into t-test. When I click on t-test, you can see there are 3 options. Independent, dependent, that is independent, pair t-test and one sample. Which is our test? One sample. Click on one sample t-test. When you click on one sample t-test, it will show you your variable. Which is your variable? Yield. Select yield inside. Okay. See, understand the steps. Don't forget that. Yield is selected. What was your null hypothesis? What was your null hypothesis? Go back to the question slides. What was your null? Yeah. Okay. The null was what? Equal to. What was your alternative? Not equal to. Not equal to what? 12. So understand this part. So based on that, we will select over here that my taste statistics, see at the bottom, my taste statistics is not 0, it is 12. What is your alternative hypothesis? Not equal to. So I will be tick marking this taste statistic. The moment I tick mark this, I'll get my result over here on the right hand side. That also you might have done in the yesterday's session. That's good. Okay. Here is my final table. What is my taste statistics? 1.84. That is my t value. T. So those who calculate it manually will get the answer as 1.84. And what is the p value? 0.1. So I've reached up to this. I've gone to t-test, one sample. I've gone to this turn. I've selected mu is equal to 12 and I've taken not equal to. That much is done. This is done. And when you click on this, you will get this result. So from this, what you can say, this is my statistic, means t value. So my t is 1.84 and my p is 0.100. This is your step 4. So what was your step 1 and 2? Step 1 and 2 was null and alternative. What is your step 3? Assumptions. What was your step 4? P value and P value. That we have done. What is your step 5? Conclusion. So now we'll go with step 5. What is the P value? 0.100. Where to compare with? Alpha. What is alpha? 0.05. So what I can say, zero point 0.1 is greater than alpha. Zero point 0.1 is greater than alpha. Greater means what? Go back again. Greater means what? We fail to reject null hypothesis. Fail to reject means we accept. What was your null hypothesis? Mu equal to 12. What was your alternative? Mu not equal to 12. So we say we accept null hypothesis. That means mu equal to 12. So now we can say that mu equal to 12. So the new variety of green gram is expected to give an yield of 12 quintals per hectare. Accept. Perfect, Pushpa. Okay. We'll take more sums because today's my first half was to give you the concept of hypothesis testing. You can see Jamovi is so easy for you. You just have to tick mark. So now it should be clear that first you have to understand your problem statement, your research problem or industry problem statement, identify what is your decision variable, identify which is the parameter they are talking about, how many samples they have taken. Then we have to go for step 1 and step 2, null and alternative hypothesis. Once step 1 and step 2 is done, then step 3 is your assumptions. Once assumptions is checked, accordingly we'll decide the test. Then Jamo will give you the result and we'll find out the conclusions for it, whether it is accepted or not. So what is this 2.58? 2.58. Why we are clicking on not equal to? Because The Jamovi, they are asking about, if you see over here, Jamovi, this hypothesis is written that is for alternative only. What are the options? Not equal to, greater than, less than. They are alternatives. So this hypothesis is to write down for alternative only. And what was our alternative hypothesis here? See, what was our alternative hypothesis? Here it is. Our alternative hypothesis was not equal to. If our alternative was greater than, we would have clicked greater than there. If our alternative was less than, we would have clicked less than there. That is the reason. Make sense? Subhashri, getting idea? Okay. So it is always H1. H1 has to be selected here. This is where H1 comes into the picture. So now you can understand at least that much, that Jamovi will make your life easy. It is a free software and it is just click by click. It is a menu driven software and it becomes very easy for you. So this was just a beginning. Okay. Then I'll take more sums on one sample for non-parametric also. Then for two samples also I'll be taking it, and this will be hands-on. So what I've done it today, I've sent you the files. If I go to the files, I'll just go explain that. I've given you the data set. In that data set, you can see there is one handout. Handouts for one sample test. So if I click on this handout, it is a Word file. In Word file, the case studies are given. It is taking time to open. Yeah, it's ready. Practice on this. I've explained one. Practice on this. If the data is not normal, how to denote null and alternative Ilongo? It is H0 and H1. This is how it is denoted by H0. H for hypothesis, null means 0. Alternative hypothesis H, and this is 1. But that notations differ from books to books. Some write down H0 and HA, alternative. So that's okay. But normally we write down H0 and H1. Okay? Sure. We'll stop over here. I think the clarity will be there about how to use it, why to use it. Now it is up to you to practice. I have given ample amount of data. Practice it today itself so that you can understand it, how it works, how decision variable is selected, how parameter is selected, how null and alternative is written, done, how to check the assumptions. All that will be clear to you. Okay, Shailila ma'am, now we'll stop over here. It's almost 10 minutes more time I have taken. Yeah, Bhagyalakshmi, huh, this all are wrongly interpreted from the books. That null hypothesis should have a negative term, it should be have a positive term. Don't worry about that all. You simply take it in this way. The question is asked, you answer it yes or no. Wherever you get an equal to sign, that becomes your null, other becomes your alternate. That will make your life easy, and which is how industry works. Done. Okay, Shailina man, it's up to you. I think she is not here. Fine. We'll stop over here. Tomorrow, Raju sir will be taking the Elongate is fine. Some people use H0 and not use any suffix. That's also it is fine. The notation changes from person to person, from books to books, from trainer to trainer. So that's not a difficult part. Yeah, ma'am is there. Yeah, I'm done for today.
If anyone wants, you can unmute yourself.
I think everyone is hungry now. Ilango, you can use H0. H0 as your null hypothesis and H1 as an alternative. Okay, done.
Okay, sir. I think there are no doubts. Sir, we thank you for taking your time to share your knowledge with us. Your presentation on parametric hypothesis testing was very insightful. Your dedication to ensuring that each participant understood the principles and applications of parametric hypothesis testing exemplifies your commitment to education and empowerment. Thank you, sir, for such an informative session. So we are again meeting on Monday, sir.
Yeah, I'll be taking on Monday. Raju sir will be taking tomorrow.
So Saturday, Sunday, there will be no class. Okay.
Yeah, Saturday, Sunday, enjoying.
Okay,
Okay,
sir.
bye. Bye.